to be doing the third question of 4.5. So let's get started. I'm given a rectangle is to be inscribed in a semicircle of radius 2. What is the largest area the rectangle can have? And what are its dimensions? Now, first thing I'm told is largest area, so I know I'm finding my absolute maximum. Okay, and we are given a rectangle, so we need to find the area of that rectangle, right? We know the area of the rectangle is length times width, and like we said before, my length is always 2x, and my width is always what we said y, which is f of x. Now here I have a little problem. I'm not given f of x, but I know that here I have what? A semicircle. Now I know that my equation of a circle is x squared plus y squared is equals to r squared. Now I'm not going to complicate it for you with all of that, so just memorize it directly. The equation of a semicircle, so if I'm going to say the y of a semicircle is going to be radical r squared minus x squared. So just memorize it like this, okay? This is very important whenever you have a semicircle. So I'm going to get my radical r squared here. I'm given r is 2, 4 minus x squared. Now let me find my area. So my area is going to be equals to 2x into radical 4 minus x squared. Okay, so that's my first step done. Now I need to find the derivative of my area, right? But here I have a little problem. This is a product rule, so I need to solve accordingly. So a prime, let us start with my u and v. So let's say I have here my u is 2x, my u prime is 2. I have my v is equals to radical 4 minus x squared. Now I need to find my v prime. So for this I'm going to be using the chain rule. By using the chain rule, I get, let me just show you. So I'm gonna take this as 4 minus x squared to the power of half. How am I gonna use the chain rule? I'm going to take the half outside. I'm gonna put the same equation in again, power minus 1, so it's gonna be negative half, multiplied by the derivative of what's inside my parentheses, which is negative 2x. Now let me just simplify, and it's gonna be negative 2x over 2 into 4 minus x squared to the power of negative half. Now the 2 and 2 are going to cancel, and I'm going to take my 4 minus x to the power of negative half down. So I'm going to be left with negative x over radical 4 minus x squared. So this is how I got my v prime. Let me just write it down. So I have my negative x over 4 minus x squared. Now let me delete this and let us continue solving. So u prime v plus v prime u, I am going to take I'm going to solve here. So a prime is going to give me 2x into negative x over radical 4 minus x squared plus 2 into 4 radical 4 minus x squared. Now I'm going to be solving step by step so you can know what I'm doing. Okay? Now I'm going to take this 2x and I'm going to multiply it by negative x. So I'm going to have my a prime is going to be negative 2x squared over radical 4 minus x squared plus 2 radical 4 minus x squared. Now, what's my issue here? I need to not multiply, sorry. I need to add my two functions, right? I'm adding two fractions. Now, can I add these? No, I can't. This is over 1. We know that. Now, what do I need to do? I cannot do that, so I'm going to change the color. I'm going to multiply by radical 4 minus x squared up and down, so I can get a common denominator so that I can add them together. So 4 minus x squared, 4 minus x squared. What am I going to get? I'm going to get my a prime to be equals to negative 2x squared over radical 4 minus x squared plus 2. My radical and radical are going to cancel, so it's going to be 2 into 4 minus x squared divided by radical 4 minus x squared. Okay, now let me go to the next step. I have a prime. So basically I'm going to distribute this 2. So it's gonna be negative 2x squared plus 8 minus 2 squared. And then it's all over the same denominator, which is radical 4 minus x squared. So I have my radical 4 minus x squared. Now my final answer is going to be, I'm just going to simplify this. So I'm going to get a prime is equals to negative 4x squared plus 8 all over 4 minus x squared. So this is going to be my, yes, this is going to be my a prime. Now, to my next step is that I need to find my critical points. So to find my critical points, this is a fraction. So what am I going to do? The first thing I'm going to do is that, now just one second, before we get to this, there's one thing I didn't do here, which is find my domain. Now to find my domain here, my domain is always going to be from 0 till my radius, in this case. So my domain is going to be from 0 until 2. Okay, let's just keep that in mind. That's on me. I forgot to say that from the beginning. So whenever I have a semicircle, my domain is going to be from 0 till my radius. Okay? Okay, so now let me move on to my critical points. Now for my critical points, I need to find, since this is a fraction, so the first thing I'm going to do is find when a prime is equals to 0, and that is always when my numerator is equals to 0, because this is a fraction. So it's equals to 0 when I have a 0 in the numerator. So I'm going to take negative 4x squared plus 8 is equals to 0. I'm going to get 4x squared is equals to 8. I'm going to divide by 4 here and here. I'm going to get x squared is equals to 2. So I have x is equals to positive or negative radical 2. Now, which value can I take? I can take the positive radical 2 because it is within my domain, which is from 0 till 2. And then the second thing I need to find is, okay, don't forget here, negative radical 2, we don't take it because length can never be negative. So I'm going to find when it is undefined. It's undefined when my denominator is equals to 0. So I'm going to take radical 4 minus x squared, and I'm going to make it equals to 0. I'm going to square my both sides, so squared and squared, so I can get rid of the radical. I'm going to get 4 minus x squared is equals to 0. X squared is equals to 4, so I'm going to get x1 is equals to 2, and x2 is negative 2. Obviously we don't take the negative, and here the 2 is already in my domain, so I really kind of literally don't take any. Now also another thing, I think here it's for the for the domain, I'm not really sure, but it's either from 0 to the radius, or we need to find the radical 4 minus x squared is equals to 0. I'm going to make sure of that point, but I am pretty sure it is from 0 to the radius, but I'll check on it and I will make another video regarding this question so I can just make, to make sure this information is correct. I started falling over my words. Okay. So now I need to get and draw my table. So let me start. I have my x, I have my a prime of x, and I have my a of x. Let me just fix my table first. So I have my domain to be from 0 to 2, and I have my radical 2 here. Radical 2 is the same thing as 1.4, so I'll write 1.4 here so it can make this easier for us. Now, for a prime of x, I'm going to be using green. My a prime of x was an a prime of x. It was negative 4x squared plus 8 over radical 4 minus x squared. So now I'm going to choose a value in between 0 and 1.4, and I'm going to be substituting it into my a prime of x. Let's say I choose 1, for example, and I'm going to get a positive answer. If I choose a number in between 1.4 and 2, let's say I choose 1.8, I'm going to get a negative answer. Now, let's move on to a of x. I'm going to use purple for this. My equation for a of x was, let me just check. So it was 2x into radical 4 minus x squared. So I'm going to be substituting into this equation. Now at my domain, it's always going to be 0. And then when I put in radical 2 into my a of x, I am going to get 4. Now, how am I going to phrase my answer? I'm going to say that they asked me for the largest area. So largest area is equals to 4 when what? I have on my length, which was 2x, and my width, which was radical 4 minus x squared. And then I'm going to substitute my radical 2. So here it should be when x is equals to radical 2. And then I'm going to substitute this radical 2 into my values of length and width. So L is going to be 2 radical 2, and my width is going to be radical 4 minus radical 2 squared, which is going to give me radical 2. And this is going to be my final answer.